Hey there, Mr. Witherow here. Today we're going to talk about greatest common factor. All right, greatest common factor, which just means the largest number slash variable term, right? Largest number slash variables or variable term that they have in common, or that's same, right? Common, same. All right, so let's talk about that. If it's just numbers, right, then we're simply just going to go ahead and list all the factors and go from there and pick the one that is the largest. So list all the factors. So remember, factors just means things that we multiply together to come up with a product, right? So terms that we multiply together to come up with the product. And then if we have variables in there, then everybody has to have that variable. All terms have to have the variable. And sometimes there's exponents on there that they have to have the smallest exponent. All right, and we'll explain that here in a second. All right, let's start with the basic ones, 18 and 20, right? So 18 and 20. So basically what I would ask you to do is just factor out 18 and factor out 20. So what are the factors of 18? 1 and 18, 2 and 9, 3 and 6, 4, nope, 5, nope, 6, there's 6. Okay, so that's it. So that's all the factors of 18. How about 20? 1 and 20, 2 and 10, 3, nope, 4 and 5, and then 6, nope. All right, so there we go. So there's all the factors of 20. So now we just simply go through here and pick out the one that they have in common, and we want the highest one. So start from here and go down. So 18 and 20, nope. 10 and 9, nope. 5, nope. 6, nope. 4, nope. 3, nope. 2, yep. 1. Okay, so here's the largest one they have. So the greatest common factor of 18 and 20 is a 2, because that's the largest one that they have. You can't do anything about that. So none of these other are in common, so we just get it to 2. How about 15x squared and 35x to the 4th, right? So again, if you break this up, if I take 15 and I take 35, right? So 15 is 1, 3, 5, and 15. 35 is 1, 2, no, 3, no, 4, no, 5, and 7, and then 35, right? 1 times 35, 5 times 7, 1 times 15, 3 times. So what's the largest number? So it looks like it's these 5s. So the greatest common factor is a 5. But now what about this x squared and x to the 4th? So let's think about that. X squared means x times x, and x to the 4th means x times x times x times x. So what do they have in common? Well, they only have this many x's in common, which means that it's x squared. That's what they have in common. Now, the easier or simpler way to do this would be just always taking the smaller of the exponents. So what's just smaller? 4 or 2? 2. That means they both have an x squared in common. So this is your greatest common factor of that. And last but not least, if we have something that looks like this, 8x to the 3rd, y to the 4th, and 12x squared, y to the 5th, again, break it up here. 8 and 12. Well, 8 is 1, 2, 4, and 8. 12 is 1, 2, 3, 4, 6, and 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. 1 times 8 is 8, 2 times 4 is 8. So what's the largest number here? It looks like it's this 4. So the greatest common factor is 4. We know that for sure. Now, with the x's, so they both have x's, so which one's smaller, 3 or 2? That's right, the 2. So x squared. And then y's are 4 and 5. Which one's smaller? Y to the 4th. That's what we have. So this is your greatest common factor. So you take the biggest number that goes into 8 and 12, and then you just take the smaller of the exponents, as long as they have them. All right? All right, the second part is when we have to factor out a monomial. So what we're going to do here is that if we have to factor out a monomial, we have to do these 3 things, sort of kind of what we just did at the end there. But this time we're going to have it, and it's going to look like a distribution problem when we're done, right? So it's going to look like a distribution problem when we're done. That's what we're aiming for. All right. Okay, so the coefficients, remember the coefficients are the numbers. That's the big numbers, right? That's the numbers that are in front of the exponents. In front of the variables, sorry. The variable is the letter. So everybody must have the letter. So everybody, all terms have to have the letter. All right. So maybe you should probably be taking notes, right? And then exponents, we want the smallest exponent. We want the smallest one. Okay, so what's this look like? So here it is. So now we have an expression, right? An expression just means that we have a plus or a minus sign. So now we have to ask ourselves, what do these 2 things have in common? So 8 and 7. Well, 8 and 7 don't have anything in common, right? So 7 is 1 and 7. And 8 is 1, 2, 4, and 8. So really the greatest common factor is just the 1. So we don't have to really factor that out. Then c squared and c, what do they have in common? They have this 1c. So that means I put the c out here, and I open up my parentheses. And then since I'm taking it out, that means division. Take out means division. So we're going to divide each one of these terms by c. Each one of these terms by c. So 8c squared divided by c is, remember, we just subtract the exponent. So let's take a look at that. Let's write that down here. 8c squared divided by c plus 7c divided by c. That's what we're doing when we're taking out the greatest common factor. So since we are division, we subtract exponents. So 2 minus 1 is 1. So this is just 8c plus, and then this go away, and we're just left with 7. So there's our answer. Notice it looks like a distribution problem. So if I distributed this c times 8c is 8c squared, and c times 7 is 7c. So what we're looking for is the largest number. We're making sure that all the terms have that variable in it, and then we want the smallest exponent. And then what's left? All right, let's try it again here. So now we're going to have this problem here, right? So 6, 15, and 3. What does a 6, a 15, and a 3 have in common? Well, it has this 3 in common, right? So 6 is 1, 2, 3, 6. 15 is 1, 3, 5, 15, and 3 is 1, 3. So you can notice that they all have a 3 in common. So the greatest common factor, or when we factor out, is that we're going to take a 3 out. Then we look at the exponents on the x's. Since they all have x's, we're going to take the smallest exponent, which is 3x squared. And then we're going to open up our parentheses. So now comes the division. That's what you have to remember, that we're dividing. So again, for some of you, you're going to have to write this down. Some of you possibly do in your head. Hopefully, as we get better at it, all of you can do this in your head and do it well. Okay, so 6 divided by 3 is 2, and 4 minus 2 is 2. 15 divided by 3 is 5. 3 minus 2 is 1. And then anything that's divided by itself is 1. So then there's my answer. And then last but not least, let's take a look at this one. It gets a little bit, now there's 2 variables, right? So we have to be careful with the 2 variables, making sure that everybody is accountable. So xy, xy, xy. So it looks like everybody has at least one xy in common. And then 16, 16, and 32. Well, 16 is 1, 2, 4, 8, 16, right? 1 times 16, 2 times 8, and 4 times 4. And 32 is 1, 2, 4, 8, 16, and 32. 1 times 32, 2 times 16, 4 times 8. So it looks like 16 is my biggest number here. So that's going to be my greatest common factor is 16. Now we all of them have x to the 6th, x squared, x to the 3rd. So I want the smallest one, which is x squared. Y to the 1st, y to the 4th, y to the 2nd. I want the smallest one, so I'm going to take a y. And then I open up my parentheses. So now I'm going to divide each one of these by this number. So 16 divided by 16 is 1, and then I'm going to subtract the exponents. 6 minus 2 is 4, and then y divided by y is 1. So that's that, plus 16 divided by 16 is 1. 2 minus 2 is 0, so that goes away as well, because remember, anything raised to the 0 power is 1. And 4 minus 1 is 3, so this is y to the 3rd. Plus 32 divided by 16 is 2, and 3 minus 2 is 1, and 2 minus 1 is 1. And then we are done. That's it. So that's what we're going to do for factoring out a monomial. Have a good one.